Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for being here again today, and it's me, Dr. Azrul. I will be here to continue my lecture topic on polymorphism, a chapter. And for today, we will be learning a new subtopic on the ArrayList class, an example of a custom stack class. Before we get into the topic, I would like to ask each of you if you still can remember what's the definition of an array, and perhaps why do we need array in our program. Okay, then let me describe its definition again in this course. As you have learned in previous semester, an array can be defined as a dynamic and sequential container or storage space called a data structure in programming for you to store data, hold data, record, or objects within the same variable type in a sequence of a table type. In short, we need array as a place to store variable and objects. However, there is one limitations on array implementation. That is, the array size is fixed once the array is created. For example, if you define an array of X should contains only 10 elements, then the array size will be fixed into 10 elements only, which means you should not be able to extend or change the array size in your program during the runtime. Other than array, Java provides the ArrayList class that can be used to store unlimited numbers of objects. The following diagrams, okay, as you can see, illustrates the definitions of ArrayList class within its specific built-in methods and operations, such as add methods, clear methods, contain methods, get methods, index of methods, and so on. However, you don't have to worry. I am not expecting you to memorize every single methods and operations from this diagram. There will be an example of a ArrayList program in the following slides. Okay, guys, as you can see and observe in these slides, the following example illustrates the example of ArrayList class implementation. If you can get through for a little while, this program can be clearly divided into 5 sections. The first section will define the ArrayList, which creates a list called a city list. And there will be several add operations or adding elements into the city list array. As you can see, adding London as the first element, followed by New York, Paris, Toronto, Hong Kong, and Singapore. At the end of this section, we can assume that we have successfully built our array list with several elements added into it, namely London, New York, Paris, Toronto, Hong Kong, and Singapore. Then we move to the second section of the program. It is clearly that this section will produce output from the system.out.println statements. What's the important things here is that you can look how this program implementing some of the built-in methods for ArrayList, which we have go through in previous slide, such as citylist.size, citylist.contain, citylist.indexOf, and citylist.isEmpty. And perhaps you should be able to understand and know what are the written types of all the methods implemented. In other words, you should be able to guess what's the output from this statement or section. Alright, then we move to the third section. We can see adding and remove operations are being invoked. At the beginning, we add a new city called Beijing into the second place or second index in the array list. By doing this, Beijing will be located in between New York and Paris in the array. And you are currently having 7 cities in your city array. The next operation is to remove Toronto from the list, and then we are going to remove the city that is located at the first index of the array list, which is New York. And now you're supposed to have a new updated list which only contains 5 cities only. Now we look into the fourth section that comes with a for looping statement. Do you still remember, or do you have any idea about this looping statement? It is a statement that will print out all the elements resided in the array list. It's pretty straightforward, and it begins with print out city that is in the index of 0 until the city which resided at the end of the array list. The output will produce altogether of 5 cities in sequence, which is London, Beijing, Paris, Hong Kong, and Singapore. And the final section of the program describe another new array list that is declared as a list. After the list has been constructed, the program invokes two add operations to store two objects of a circle with a different radius value, right? 2 and 3 in the index of position 0 and 1 respectively. And finally, the system.out.println statement will produce an output that displays the area of the circle which represented by getArea methods at the index equals to 0, which the circle that comes with radius is equals to 2, that is 12.56. Okay, you may observe the output here in the slide. Okay, besides ArrayList, Java also provides another type of data structure called a stack to store and hold data or information as similar as what ArrayList did. If an ArrayList stores data or information in the sequential list type, or perhaps you can imagine it as a horizontal list type, storing data or information from left to the right according to the index position. However, a stack comes with a different approach. That is, it stores and holds data in vertical representation. You can imagine a stack just like a vertical container or a bottle without a cap. A new data will be inserted from the top of the bottle and goes directly to the bottom of the bottle if the bottle is empty. To delete a data or object, stack will select and remove the data that is located at the top of the bottle. The add and remove operation of a stack can be easily understood by following the concept of LIFO or LIFO, which is the last in and first out. Any data that is the last be inserted will becoming the first data to be deleted. The diagram in the slides illustrates some operations that can be implemented in stack. However, there are three common operations in stack. Call it as a push method, which is to insert or add new data. A pop method is to remove or delete data at the top position of the stack. And a pick method which to retrieve data that is located at the top position of the stack. The next following slide. Okay, the next following slide describe an example of ArrayList program that is implemented through stack operation. At the beginning, we declare our array list called list in the program, and there are 7 built-in methods showing their operations and its return type. You may observe those methods maybe during your hands-on or lab session. Then we create another class for a test program called test my stack. As you can see in the main method, we created an object called stack for my stack class. Then we have a for looping statement in order to insert new data into the stack. Overall, we insert 10 elements into the stack. In the final section of the program, we can observe a statement that to check whether the stack is empty or not. If the stack is not empty, then we invoke the pop operation, which to delete the elements in the stack. We delete the data until we found that the stack is empty. Once the stack is empty, the program will stop and quit. The output of the program is shown in the box down there. I would suggest that you could try to implement this example in your Eclipse editor for better understanding during the lab session later on. And for that, I believe this is the end of our topic for today. Thank you very much for watching and your participation. I end this presentation with Tasbih Kifarah and Surah Wang As. Wassalamualaikum warahmatullahi wabarakatuh.